In this video, we're going to learn how to solve logarithmic and exponential equations using a graphing utility. So when I see this first equation, if I try to go and solve this, my first inclination is to get the e to the x by itself. So I would subtract x, and I would get 2 minus x, and then I would think, let's switch this to its logarithmic form to get the x out of the exponent. So I can rewrite it as x is equal to natural log of 2 minus x, and now I'm in the same predicament that I was the step before, is now I have a variable within a log, and to get that out of the logarithm, I would put it back in exponential form, and it would be an endless loop. So we can't solve this by hand. We're going to have to use technology. So this was just a dead end. So instead, I'm going to graph two functions. y1 will be x plus e to the x, and y2 will be 2. So if I go to my calculator and I go to y equals, I'll plug in both of those functions. X plus e to the x, and my other function will be 2. And where these two graphs intersect will be the solution, because if that function is equal to that function, that's only where the two graphs would intersect. So then I'm going to find its intersection. So go to the graph. That is my x plus e to the x function, and there's the line that goes through it. That function is going to grow forever to the right, so that's going to be the only intersection point right there. So in order to find this, I'll hit second trace to bring me to my calculate menu. The fifth option is intersect, hit enter, and it says first curve, and right now I'm on my x plus e to the x curve, and I'm going to put it near my intersection point and hit enter. It now switches me to my other curve, as it says to make sure I'm still near the same intersection. I'll hit enter, then hit enter again to guess, and it'll guess the intersection point, which is 0.44, and this one's 2 decimal places, so I'll stop there, comma 2. So the solution will be its intersection, which will be the x value of its intersection since I'm solving for x. So my solution will be x is approximately 0.44. Now let's try it with the next example. Another thing that may happen is both of your logarithms have different bases, which will make it very hard to get rid of both of them. Because as you get rid of one, again, you'll still have the other logarithm, and it'll put it in this endless loop, and it'll be very difficult to solve. So we're going to graph. But what should y1 equal? I don't have a log base 5 key in my calculator, so I actually need to rewrite this equation to help me out using the change of base formula. I do have a log key, so I can rewrite this with a change of base formula as log of x plus 1 divided by log of 5 minus log of x minus 2 divided by log of 4 equals 1. The left side here will be my first y equals, so log of x plus 1 divided by log of 5 minus log of x minus 2 divided by log of 4, and then my y2 will be the function of 1, what it's equal to. So those two equations on either side of my equal bar, I'm looking for their intersection to find my solution. So let's go to y equals. I'm going to clear out the other two functions. And be very careful as I plug this in. I'm going to put my first fraction in parentheses to make sure it stays as one fraction. So log of x plus 1. Close the parentheses on the log. Divide the log by log 5. Close the parentheses on the log. And then on the fraction itself. And then minus and do the same thing for the other one. We'll have log of x minus 2. You notice I put that parentheses before I started. I'll close the parentheses on that logarithm, then divide by log of 4, close parentheses on the logarithm, and then on the fraction. And now I've made that y1 function. y2 will just be 1, and we'll look for their intersection. So it's definitely hard to see, but the graph doesn't just pop out of nowhere. There's probably a vertical asymptote right there where it climbs up. It just gets so steep that it can't register what its value is. If you wanted to see more points, if you go to Window and you see this res, if I make it a little bit bigger, I could possibly get a graph that could go a little bit higher, but it is so steep, you're not going to see it. But now let's look for that intersection point. So second trace, intersect, and on my first curve is this logarithm. So I hit right until I see it pop up on the curve. Yeah, you'll see here that if I go too far left, it's undefined, because for any value that's less than 2, the domain of this function is everything that is greater than 2, since anything less than 2 would make that negative. So that's why you don't see it pop up here. But 2.1 should pop up and everything to the right. And our intersection point's about right here. So I'll hit enter near the first intersection points. Then the second curve's on that 1. The intersection point's about right there. I'll hit enter one more time, and it'll guess that my intersection points is 2.79 when rounded to 2 decimal places, comma 1. So my solution would be x is approximately 2.79. Now, sometimes you might have an exponential and a log within the same problem, and then you'll definitely need to use a calculator again, because again, swapping between the two, trying to solve it, will be a dead end. You'll kind of loop back and forth and you won't get anywhere. So I'm going to graph. My y1 will be e to the x minus natural log of x, and my y2 will be 4. So go to y equals, clear them out, and we have e to the x minus natural log of x, and then 4, graph. There's my e to the x function. And I see one intersection point, but one thing you should also know about this function is its domain is all positive values of x, because the natural log can't have any negative values or 0. So you'll see here at the very bottom of this curve, it actually starts curving back upwards. So I'm actually going to zoom in on this graph so you can see what's happening right at that spot. So I'll pick that spot right there to zoom in. You'll notice here it's actually curving back up to the along the y-axis. So there's actually going to be 2 intersection points for this problem. So we'll have to do this process twice. So let's look for where our intersection is. I'm going to find the one on the right first. So my first curve is the e to the x minus natural log of x function. I'll put it near that first intersection point. Then keep that cursor near the same intersection point for my other function. Then enter one more time to guess. And one of my points is 1.48, comma 4. And the reason why we do this thing where we pick a spot near a certain location is there could be multiple intersection points. So I'm guaranteeing I'm getting the right one by doing this. And if I do the problem again, I'm going to shift my cursor over to the left and put it near the other intersection point, which is about right here. Hit enter. Then my second curve is 4, so I'm going to pick a spot near the intersection point again. Then enter one more time to guess, and it'll guess that the other intersection point is 0.05, comma 4. So my 2 x values that are possible solutions are 0.05 and 1.48. So you'll have to use a graphing utility if it ever seems impossible to do algebraically. And that is how you solve logarithmic and exponential equations using a graphing utility.